All right, Ocean College, here we are. We're going to talk about elasticity in economics, elasticity of demand, more accurately, and supply. All right. A couple of things. First off, here's the things that we're going to cover, and it may be in a couple of different videos, only because I only have about 15 minutes in each one of these, because I'm using a free screen recorder at the moment. My camera is broken, so we're going to use some of these really cool PowerPoints that are from your book. You're going to love them. Why economists, I'm sorry, here's what we're going to go over, all right? Why economists use elasticity to measure responsiveness to change in prices or incomes, why the price elasticity of demand, the income elasticity of demand, and the cross-price elasticity of demand are important indicators of consumer behavior in response to changes in prices and income. Why the price elasticity of supply is an important indicator of producer behavior in response to changes in price, very important. What factors influence the size of these various elasticities? Before I get started, I just want to tell you what elasticity means. So basically, elasticity is how sensitive the demand or supply of a product or service, how sensitive it is to price changes. So if I go from $1 to $3 for my can of Coke, will people demand it less by a lot, or will they demand it less by just a little bit? Because that means I can fluctuate this price pretty good and still make some good money. But we won't know. So this is a cool example. Ambulance rides. I would assume, and we'll look over it, I would assume that the elasticity for demand for ambulance rides is pretty inelastic, which means that no matter where my price is on the scale, people are still going to demand the same amount of, or at least pretty close to the same amount of ambulance rides than they were before. Only because there's no substitute for ambulance rides, unless you get in your car and drive to the hospital yourself, which is difficult if you're in dire need of an ambulance. But ambulance rides, ambulances know these. Companies know that ambulances are pretty inelastic, which means they can charge basically whatever they want. But there are competing ambulance companies, so that may change it just a little bit on there. My son's sneaking in here, so let me just pause this for just all right, sorry for that. So here we go. We know there is an inverse relationship between price and quantity demanded for ambulance rides. The same thing with anything else. But how much does the quantity demanded change when the price changes? So I'm guessing, and it's an educational guess here, that ambulance rides are going to be pretty inelastic. So a demand curve is elastic. So this will just go over what elasticity kind of means a little bit further into the explanation I gave you. So consider here the rubber band, how elastic it is to you pulling it, right? A demand curve is elastic when an increase in price reduces the quantity demanded a lot, and vice versa, right? It didn't go there. Here we go. When the same increase in price reduces quantity demanded just a little bit, then the demand curve is considered inelastic, which means that no matter what your price is, people are still going to demand it the same. If you have a product that's very elastic to changes in price, you don't have a lot of wiggle room in moving your price around. Okay, when they are inelastic, that means you have a lot of wiggle room in increasing and decreasing your price. All right, as we can see here, this is an inelastic curve. And the reason I say that is because, and this is for demand for ambulance rides, is you can see that even though the price went up by, I think this, okay, you see this here, this means 1, 2, skip a few, 99, 100, right? So that means you went from 1, 2, 3, 4, 5, skip a whole bunch, and now we're in, this is actually 200, and this is $210. This is 9.9 million, and then 10 million here. So at point A, we have at $200. I know it says 20 here; it's really confusing. But at $200, we see that 10 million ambulance rides are demanded. I'm going to assume this is per year. Okay, so at 10 million are demanded there at $200, and there's not a big change here. 9.9 million are still demanded at $210. Okay, so when prices rise to $210 per ride, the world demand falls to 9.9 million rides per year. Okay, good. That is true. To point B, how do we categorize this? Is the demand elastic or not? It is not, because when there's a high percentage change in price and a very low percentage change in quantity demanded, you would say that this is inelastic. It's not very elastic at all. And here's an example of an inelastic demand curve. All right, so let's say we have a change here from $40 to $50. All right, so $10 change there, and there's only a 5% or 5 quantity demanded, change in demand, about 5 there. That's not too bad. But if it is elastic, and you'll see a curve that's a lot more flat, and a demand curve that's flatter, then you'll see a big change in quantity demanded for your price. That means this person doesn't, whoever is producing whatever this is, doesn't have a lot of wiggle room to increase their price. That tells you something about your product, that if somehow I can keep my prices at a certain price point, because if I can sell 80 at $40, I'm making some pretty good money. But then when I only sell 20 at $50, I'm not making as much money as I was selling 40 at 80. So I have to be very careful. I have to keep my prices down and my costs down, so I can keep my prices down and keep people interested in buying the product. So if I have a product that has a very elastic demand curve, I have to be very careful in how I increase or decrease my prices. And if I have a inelastic demand, such as gasoline or things that have very little substitute, then I know here then like toilet paper, flushable toilet paper, all those kind of things are very important. But they don't have that many substitutes. They might have a lot of people in the market, but they don't have a lot of substitutes, right? So that would be someone I can change prices on and not worry about the quantity demanded on there. Yeah, so this is just saying the same thing we just looked at there, that at any given quantity, the curve that is flatter is more elastic. Price elasticity of demand. Now here is here's a really good way of doing this. So you can check out this formula, which is very important to you if you have any questions for that. Price elasticity of demand, so how elastic demand is determined by the percent change, okay, percent change in quantity demanded divided by the percent change in price. Okay, so if I had, let's say I changed my price from $1 to $2, I would say that was a big change in percent change there, right? So if I went from $1 to $2 was the yep, sorry, so, my son just rolled up again. If I had a change here, percent change in price, I would change, so I'm sorry, price elasticity of demand is equal to the percent change in quantity demanded divided by the percent change in price. So if I'm changing from $1 to $2, that's my percent change that I'm calculating, from the $1 to $2, and then I'm going to change which is about 50%. So then what's my change in quantity demanded? My percent change, whatever happened there. So if I went from 50 to 100, you have to just kind of look at that and figure out what your percentage change. And I'll go over that here in just a moment. So here we go. So if the price of oil increased by 10%, whatever your percentage change is, and the quantity demanded falls by 5%, then the price elasticity demand for oil looks like this. Okay, this is how you would calculate it. 5%. Since we know the price and quantity demanded will always move in opposite directions, law of demand, we usually drop the minus sign, right? It's always inverse. And that's why they give you so what we would say is we would get the absolute value of the end here. And all absolute value means in mathematics is that we just drop the negative no matter where we are. So absolute value of negative 0.5 is 0.5. All right. The absolute value of 0.5, positive 0.5, is also positive 0.5. So all we're doing is making a negative number into a positive. That's when you hear absolute value. That's what that means. There's a problem. And here's the toughest thing. It's not the toughest thing, but if you If let's say you jump from 0 to 100 and from $0 to $100, that's a huge leap. And of course, demand is going to change dramatically for whatever product that had a $100 leap in price. And so that is going to skew it. It's going to make it seem as if that were a very elastic product, but it may not be. So to figure that out, we have to find the midpoint formula of percentage change, which means we find the average. Okay, so instead of dividing by the initial quantity or price, we'll use the average quantity or price. So our formula is going to look like this. We're going to find the percent change in X. So to do that, we're going to take the change in X, divide it by the average value of X times 100. Now to find the average value, we start with the starting value of X plus the final value of X. So if we started at $1, then we add it to $2, and that gives us, so we start with $1 plus $2, divide that by 2, and that's going to give us the average value of X. So if we went from 1 to 2, that's $3 divided by 2, and it's 1.5. So we got 1.5 would go here in our formula, and then the change is from 1 to 2 is only 1. So from 1 to 2 is positive 1. So we have 1 divided by 1.5 times 100. And if you had your calculators out, it'd be 1 divided by 1.5. It's 0.66. Times that by 100, and that's going to give you 66.6%, which is not a fun number, but sorry for that as your example. But that would be your percent change in X, and I'll show you that here. We'll start here. Initial price of $10. The quantity demanded is 100. All right. When the price rises to $20, the quantity demanded is 90. And this is just an example that's given to us. So let's look at this, our formula. Let's find the percent change in quantity demanded. First of all, we take 90 minus 100, right? So 90 minus 100 gives us what? 10, positive 10, right? And with a positive 10, so we have 10, and then 100 plus 90 is equal to 190. Divide that by 2 is going to give us 95. So we're going to get 10 divided by 95. It's going to give us 0.10526. So we're going to multiply that by 100 to give it our percentage, and that's going to give us 10.52, but we're going to just round it to 10.5%. And we have a negative, of course, but that's 90 minus 100, so it would have been negative 10. But we're going to get rid of that negative and make it an absolute value. So that would be 10.5%. Now that we have the percent change in quantity demanded, we're going to find the percent change in price. So we got the quantity demanded, so that's 190. We got that down to negative or to positive 10.5%. We're going to do the same thing here. 20 minus 10 is going to give us positive 10, and 10 plus 20 is 30, divided by 2 is 15. We're going to take our 10 divided by 15. It's going to give us 0.66666%, and then we're going to 100 times that by 100 and get 66.6%. That's going to give us what we need now. Now we can actually do the price elasticity of demand. Negative 10.5% divided by 66.6% is equal to 0.15. 0.15. And since that is less than 1, that would be considered an inelastic demand curve. All right, I'm just going to skip that so we can hurry up here. Skip this as well. Well, here, I'll show you just real quickly. They have some ideas here for gasoline and for the short run gasoline, long run gasoline. And you'll see that their price elasticity of demand is inelastic because there's not a lot of substitutes for gasoline, airline, soda, college. Now, if we broke it down to between Coke and Pepsi in our sodas category, there is a big elasticity of demand because as soon as Coke raises their prices, people will start buying Pepsi. And as soon as Pepsi raises their prices, people will start buying Coke. And so there's a big, huge change there in that case. Now, here's how we did it. So at the end of it, if we can get, after our formula, if we find out that in the end, if what we discovered, elasticity of demand, the absolute value of elasticity of demand, so before was 10.5, was 0.15. If the elasticity of demand, absolute value, that's what these two lines are. It means absolute value of our elasticity